Coming up on This Week in Radio Tech, Jake Alderman is my guest. He's going to help us understand the difference between a virtual machine and a containerized software like Docker. Is the difference important? We as engineers, as broadcast engineers, do we need to know about this? I think the answer is yes. It's coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionic Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb right there at the top of the tower. I'm Kirk Harnack, glad to be with you. I'm in the Telos Alliance studio in Nashville, Tennessee, and I'm ensconced in my bunker here essentially in the basement of the house, although there is a window out here to the backside of the house, and this is where we hide out if there's bad weather. And there's bad weather today here in Nashville. So, if you're watching this sometime down the road and it's not real time, you're not watching live, don't worry. The bad weather was just here on this date, Thursday, March 25th, 2021. We will shelter if we have to, but we got some tornado weather about today. Hey, I'm so glad that you're here because we're talking about something that has been near and dear to my heart for a long time. And we're going to do that with a gentleman who is also near and dear to my heart, Jake Alderman. Jake, welcome into the show. Good to see you.
Thanks, Kirk. Really excited to be here. Second time around for me. First time doing it the remote way. The last time you were a few times ago when you were in Cleveland, we did this when I was in our customer support team. So
that's
excited
right.
to be on the show again.
That's right. So you have, that was so long ago. You've moved from customer support into a responsible position at the company, haven't you?
Yes, I'm the program manager of virtual solutions. So I get to play the role of helping to coordinate as we bring this new family of products to market, like Telos's IQS and our VXs solutions that are taking the code that has been great for years in our hardware product and putting it into a software format so we can deliver it to you on the metal you want to bring to the party, so to speak.
This is a topic, Jake, that I've been talking about for years, literally years, at NAB shows, Wisconsin broadcasters, Tennessee broadcasters, anybody that would, Michigan broadcasters, WABI, CCBE, anybody that would listen to me for a while. And in fact, I think we kind of started talking about this back when our company founder, Steve Church, was still alive. The whole idea of virtualization and what that would mean for broadcasters, what it would look like, what engineers would need to learn. And Jake, as I've been finding out, and I guess you kind of know this, you got to keep learning stuff your whole life. And a good example of that is back in 2004, maybe? Yeah, about 2004, when Steve Church and Michael Dosh co-presented a paper at the NAB about audio over IP. And I got a copy of that paper. I didn't get to attend it in person, but after NAB was over, I got a copy of the paper and I started reading it. And I read it and I thought, I don't know if I understand this. This is a weird concept. Usually we wire outputs from one machine into inputs of another machine, and oftentimes there's a punch block or there's a jack field or something in between, maybe a distribution amplifier, but there's gazoutas and there's gazintas, as I always say. And to wire things up in a network fashion, and I scratched my head. And Jake, I got to tell you, I read that paper literally 5 times. It sat on my kitchen table and I read that paper 5 times. And the 5th time I'm reading it and I go, oh, this really is this is like printing to your printer over the network. This is like you have shared resources and shared destinations, and wow. And then the ball started rolling. And then I started, educating other engineers about what this meant. And it was a slow process because it was like this whole new idea. And so now we turn our attention to virtualization and all the things that can mean. And it can, excuse me for taking up a little bit of time here, but Jake, virtualization can be so many things. We used to have cart machines, and then back in, I think 1989 was about the first year, that some of the automation systems came on the market, and I mean not the reel-to-reel ones, but the ones that were computer-based. Smarts, for example, came out with an early one that would play commercials, and the audio was not that good. It was 8-bit audio, and it was maybe stored in ADPCM format. It wasn't that good, but it replaced your cart machines, and it lets you run much more unattended than you could with cart machines. And that was an early form of virtualization. You took what was a cart machine and you put it into a general purpose device, a computer, and told the computer to, hey, you act like a cart machine. Here is a program that makes you act like a cart machine, and you're going to do that. You're going to look for contact closures to start, and you're going to play these commercials out of your audio. And then when the last one's played, you're going to shut up. And that's what cart machines do. So we've gone from that kind of virtualization to where we are now and where we're going, Jake. And maybe you now can pick up the story where I kind of left that off. We've been virtualizing. Well, think about this. Our audio consoles at Axia and other companies as well. Now you have a computer that is taking digital data, mixing it together based on commands from a surface, and then outputting that as new audio. It's no longer VCAs and amplifier and mix buses with low noise, low impedance inputs on the chips, and then going out. It's done by general purpose computing devices. So, okay, now, Jake, kind of pick that up and kind of tell us where we are with this whole notion of virtualizing stuff.
So yeah, I mean, it's perfect to look at something like Livewire as a technology that was a genesis point to moving out of physical hardware and into general compute devices. We start that journey, a lot of people, I don't think, look at their Livewire network, the network being the benefit, right? It's the functions that a console delivers. So the fact that I can push the source button on my console and I see 30 sources that are spread across my entire system, that's really what's wonderful about having a Livewire system. And we facilitate that desire via delivery of the network, right? The enabling technology is the audio over IP, but the actual magic is the source list. When I click my Fusion, I get my list of sources. And so that premise over and over again was great. And we took physical consoles and we put them in a metal box for you. Now, let's put that in your metal box, right? So you already, as a station owner, are buying general compute devices. You're already buying large servers to deliver business services. Rather than, putting another dedicated hardware box line, which we still will make and sell to you. There's no way tomorrow Telos is waking up and we're not going to have the studio engine available that goes with our Fusion or our Quasar console, right? That will be there for some time to come. But if you're looking ahead and you're saying, I'm going to build a new shop and I need a phone system and some production room consoles, and man, that's a lot of metal that's just coming from Telos. Why don't I put that all in this one unified piece? That's where the power of virtualization can be leveraged. You're right, virtualization is somewhat of a vague term, and the terms we're discussing here today, we're making the shift from taking it out of hardware and into software was the first jump. That's the one that Axia made. Now we're making the jump to be in the IT-centric term, which is the fun world of hypervisors and containerization and all these big IT trends that have been going on for the last 10 plus years that are sort of mature enough that we as broadcasters can adopt them and bring them into the facility, just like the network became mature enough we could adopt it and bring it into the facility for our real-time audio production needs.
I was just thinking back over history. Steve Church, his claim to fame back in 1984 was he added digital signal processing, DSP, into a telephone hybrid to improve its performance. It wasn't all DSP, but the DSP improved the performance of the analog portion of the hybrid. And DSP is a form of virtualization. It let us have software controlled audio functions in a piece of silicon in a chip, and then we moved on to and please remind me the name of these things, the Xilinx chips that are so often used. What are those?
So yeah, there's a variety of vendors that we use for embedded CPUs in our products today. So in some products, there's an Intel-based chip. In other products, we use Xilinx is one that comes to mind. We've we've got a variety amongst our different hardware products because the product teams pick the processor that's most appropriate for the need.
The word I was trying to think of was an FPGA, field programmable gate array.
Yes.
So an FPGA gives us the ability to do some very sophisticated functions, different than a CPU, but still, to let us program things in and let us do again some sophisticated functions. And then, of course, we had Omnia audio processors. Now audio processors are based on pretty standard operating systems, or tweaked a little bit, but running on fairly commercially available hardware. Somebody could go buy the same stuff that we buy. And so we went through the FPGA period. I guess now we're not probably doing as much with FPGAs as we were, because we're really writing software, writing programs to run, first of all, on our own hardware, as we have been for a few years. That's where a lot of the industry has been. Plenty of other manufacturers in our business are doing that. They're using general purpose CPUs, of various capability in their devices, and they're writing code that goes in there. And so are we. And now I guess what you're doing is taking this code that's been running in boxes or appliances that engineers are used to buying, and they're saying, you know what, we can make this code run on an even more general purpose device, that is a server or other workstation type platform, and let the user have control of the hardware. And the LiveWire or audio over IP, AES-67, for example, in and out of that device, that makes the audio gazintas and gazoutas possible. You no longer have to have a special audio interface. Isn't that right?
Right. So the move to the AOIP protocols, AES-67, LiveWire, SMPTE 2110-30, which is very similar to AES-67, those protocols are the foundation of our facilities today. There still is a place for analog audio. I was just having a conversation with someone today about the need for an HX1, which is a hardware-based phone system Telos makes that uses POTS technology, right? That still has a sector in the marketplace today. But there's an evolving need of I'm buying a console, and that console is nothing more than software with maybe some buttons, but maybe I'm not even using the buttons. One of Telos's partners, or a number of Telos's partners, have developed software-based interfaces, Broadcast Bionics for the VX. You can deploy your VX with no VSets, and you can buy their software to do call control with it, right? And that means that now you've got a hardware box from Telos with a software control interface that's brought to you by Bionics. But there still was this one piece of metal you had to buy from Telos, and it just did one job. Well, with VXS, what we've been able to do is now the deliverable from Bionics' software and the deliverable from Telos' software. So if I've got both of those pieces of software, I can buy one really powerful server and start putting all of that into a central rack location. Now, it's not to say those two jobs necessarily run on the same machine, right? They might need to run on different computers due to operating systems and delivery methods of that software. But once it's all software, we're starting to look at more generic compute hardware. And just like anything as broadcasters, we all know how important relationships are with our vendors, whether it's who you buy your gear from, or whether it's who you actually, your IT staff in your own organization who does a lot of purchasing. And the more you can leverage those, the cheaper some of these solutions start to become. So one of the big questions I always get is, well, that server is going to be $2,000. Well, there's a bunch of ways to drive the cost of bringing a server into the facility down. You can drive the cost of bringing a server in by buying used, right? I think you and I a year ago were having the conversation about how do I buy a good server out of a data center from one of my stations, right?
I got to tell you, down in my lab, which is down the hall in the basement, I have 5 Dell servers. They're all prepped and ready to go back to my radio stations in Mississippi. I've got them all configured, and they're about $2,000 worth for 5 servers, $400 a server. Yes, they're off lease. Yes, we'll have a problem with them before the original owner would have, but they got a lot of life left in them, a lot of computing, and then they are hosses. They sit there and run, they great hardware. So they're just going to sit there and run 2 power supplies, lots of fans. A fan can fail, no problem. It'll warn you on the front panel, but it'll keep on running. I'm sorry. Go ahead. I'm so impressed with getting off lease servers.
Right. I mean, so if you're going to buy hardware, an off lease is a great choice. If you're in a budget constrained situation, an off lease, just make sure it's going to match the operating system you're going to run. Make sure it's going to match, all the technical requirements of whatever you're going to deploy, whether it's our product or you're doing a business function, right? A PBX. That's a great way to get hardware into the facility. Also, it is shocking to me. I was the engineer at my college station, how great the discounts at some organizations are. So when you actually reach over the wall and ask that IT department, hey, we're doing a project, and I was wondering, do we have a relationship with a Dell or an HP or whoever the provider is for your org? And they go, oh yeah, we have a relationship. The percentages are normally double-digit percentages off that your org is getting on enterprise equipment, whether it's Cisco or whether it's HP or Dell or any of those type of vendors. There's some pretty steep discounts out there on that gear. So, the hardware cost, and it's similar on the cloud front, by the way, when you start looking at starting to move towards an AWS type solution or a DigitalOcean or an Azure, again, the corporate IT folks have pretty good arrangements with those guys that, hey, can I get a couple spare compute credits? Oh yeah, your pennies, fine. Go over there. Compared to running the whole org off this system, yeah, whatever. Just don't break anything. If you have those strong relationships, it's pretty easy to start to leverage getting the tech to start to deploy, or getting some parts where you can deploy and test these new virtual products out.
So in the coming part of the show, we're going to be talking about things like an IP audio driver and how does that work? What does it need in terms of environment in order to work? We're going to be talking about something that we've been doing for a while, which is stream encoding in the virtual LAN, in computer space. We're going to talk a little bit about latency. That's a concern. About also what is a real-time operating system, and what and why we may not be able to run a real-time operating system in the virtual world, and what does that imply for broadcasters. We're going to talk about something Omnia 9 Enterprise, which there's hundreds of them now out in the field, it turns out. We're going to be talking about this thing called IQS. This is a virtual audio console, runs in a CPU, general purpose CPU environment, and as you mentioned, VXs. The Telos VX running in software. And I also, when we come back, I kind of want to understand, first of all, Jake, why we can't just run an app. Why can't I just buy from Telos an app that's going to run on my Windows machine? Why is that not the way to go typically for low latency broadcast reliable environments? So I want to hear your answer for that. And if we're not buying apps, what are we buying? Where are we going with these virtual infrastructure things? So that's coming up this week in Radio Tech. I'm Kirk Harnack. Jake Alderman, my friend from the Telos Alliance. He is the program director for virtual stuff. He's our guest today. We're going to find out those questions about apps and Dockers and virtual machines and why we are doing things the way that they are, why that's important. Our show is brought to you in part by our friends at Broadcast Bionics. We'll be right back.
Hi, I'm Phil from Broadcast Bionics in the UK, and we've been helping broadcasters and podcasters to work remotely for some time. But in 2020, this has become more of a necessity for many. Xscreen, Bionic Studio and our other products can be fully functional via the internet on a VPN connection or RDP session. If you have any type of Telos VX, HX6 or IQ6, you may already be using the free edition of Xscreen 2, giving you a software interface to go alongside your VSET controller. The subscription edition not only adds a cloud database and unrestricted workstation licenses, but also allows the user to call screen using a USB headset. Bionic TalkShow, part of the Bionic Studio, also allows this. Up until now, it's mainly been used for remote broadcasts, but now more and more stations have call screeners and producers working from home or socially distanced offices. The teams can still collaborate, communicate and deliver programming with the help of our tools. Many routers will have a VPN option. Your local IT specialist can help with this. Using a VPN, our workstation client software can be run on a home PC or laptop as if it was running on a machine in the studio. With Remote Desktop, the software still runs on a PC at the station. Simple port forwarding on your router may be all that's required to then control that PC and deliver the headset audio from another device using RDP, which is available as part of Windows. For technical help, our support team are on hand. You can email them on support@bionics.co.uk. Combined with our Anywhere and Skype TX for radio products, broadcast quality audio can be delivered from contributors around the corner or around the globe. They can even instant message with the shared chat windows and see the now playing information from within the Anywhere remote web interface. For more information, go to bionic.radio. We're helping broadcasters around the world to adapt to the new normal with innovative tools from Broadcast Bionics.
They make some cool stuff. You can get them at Broadcasters General Store as well. So check out bionic.radio. And if you want to buy something, you can certainly talk to our friends at bgs.cc, Broadcasters General Store. Hi, it's Kirk Harnack along with Jake Alderman. We're talking about virtualization and in a practical sense what that means, and to help get us even more our heads wrapped around where this is going, because trust me, it's going there. It is absolutely going there. I mean, in 10 years from now, you need an audio processor. Will you buy an appliance audio processor like you always have for radio, or would you get a service, or would you put it into a server, that kind of thing? And Jake, I wanted to see if we could get past this one question that I often come across, and I've had myself, and that is, when can something that we do virtually be an app? When does it need to be maybe a service in Windows, like our Zipstream software that runs as a service? And when does it need to be something even different, a virtual machine, or this thing that I'm just finding out about called a Docker, or a containerized software? What's the right place for these different deployments?
So I always start when designing a system with what's the job I'm trying to accomplish. And that question governs a lot of what you're deploying, right? So again, like I mentioned, I was talking to someone earlier today about the need for a POTS hybrid, right? Pretty clear we're not going to go the virtual route there, because to go the virtual route for that hybrid, you're going to need a hardware piece of gear. You're going to need a gateway where you plug your POTS line in. That turns it into VoIP. Now I can connect that to my virtual hybrid. That's not really a logical workflow. By the time you deal with all the headaches and hassle of putting that together, you should just buy a POTS hybrid, right? Those are still out there. They're well developed. We all love them and trust them. Then the moment you get into, I'm delivering a more complicated or integrated solution, something like a console, like our IQS, that's going to have a software-based interface only, and it's going to, IQS does not have a surface that goes with it. The surface is in your HTML5 browser. Well, now the question becomes, okay, how much isolation is required to run that? And
by the way, just to let people know what you're talking about in case they haven't seen it, I turned my camera around, and this is my second monitor on my Mac. I'm actually open an extra tab from the Chrome browser on my Mac on the second monitor, and I have it here, just browsed into the engine for this, and they see I can run these things up and down. If I had a touch screen, I could do this with a touch screen. By the way, the power just went out here. I guess I'm still connected. That's good. And oh yeah, the power did go out. See, all my stuff across the room is out. So I'll let you go ahead, and I want to show people what IQS was. It's a software, but it's a virtual audio console. I'm running it on a little appliance that the folks at Telos Alliance make, but you can also just run it on a PC that's running Linux with a Docker engine. So I'm sorry, go ahead with your explanation.
Right. So the IQS, thank you for the demo of that, Kirk. I appreciate you having the resource available. We've got this software, and we've got this console, and it's going to be purely software. So at that point, the question becomes, how do I virtualize it? And so then there's two choices. There's the concept of a virtual machine, which we're getting more and more used to working with every day. And that's, we have a piece of software called a hypervisor, and that piece of software creates false computers. It virtually, you get memory and CPU resources allocated and network interfaces, and it creates all the things a physical computer has. And then you can install an operating system, and then you, on top of the operating system, can install applications. with IQS, it's available either on the AE1000 from Telos, which is a 1RU metal box we make that delivers a single instance of IQS, or it's available as a Docker container. And so Docker is a compute platform that it's available on, and the container is a more generic wrapper of software. And what that container is it packages up all of our dependencies and our software and its dependencies. So one of the notorious things about delivering software products is I have to have all these dependencies met. I have to have submodules installed or other applications or whatever it is to make it run. And so what a container does is you can put all of that into one contiguous unit and deliver that to customer. Or to your, and by customer, I don't just mean an end customer like Telos does, but an internal IT team as well, and they can deploy it at scale. And so it's this layer of abstraction. And the reason we choose these technologies over choosing a standard desktop style application is reliability. I think we all like to sleep easy at night. I know when I was a station guy, that was my number one design principle, right? How can I design a system that if something goes wrong, the staff that's there overnight can just take care of it so my phone doesn't ring, right? That it fails, it notifies them that they've lost a resource, or it backfills with another alternative resource so they can just keep running. And my phone might ring to tell me it's broken, but I'm not getting in the car and driving over to the studio to fix it. And that's the same premise for a lot of IT organizations. And so containers have been embraced by some of the largest companies out there, and people in broadcast. The closest thing we have to our IT needs is financial services. PayPal, MetLife, and Visa all are back-ending a lot of their systems on containers. And I know I'm sitting here thinking, right, when someone trots those case studies out and says, well, my insurance claim not going through is a little less critical, Jake, than, my real-time audio. The beauty of how these systems can, and there's a reality here. Things do go wrong, right? There is no system that's going to be fault-free. But when we have a fault, we want to recover as quickly as possible from those foibles. And so containers, what they allow us to do are scale up quickly when we see a failure happen, whether it's a whole compute node going down and we need to move to another piece of hardware, or just something causes a bug and it crashes and we have monitoring in place and can quickly bump and restart that instance for somebody. You're able to bring those services online quickly. So the one that I like to use is PayPal does all of its payment clearing through a container-based system. So the moment you say send your money to your buddy, the moment you say send your money to your friend, all of a sudden that you type in their username, you log in, it does all of that processing. Or PayPal, when they collect it from a business perspective, they do all their payment processing through a container-based infrastructure.
Now, not through one container. I guess it's a lot of little containers doing different stuff, talking to each other, right?
Exactly. And there's a design principle that goes behind containers and even hypervisors, and that's called microservices. And at the top level, what a microservice is it's the process of saying, instead of I'm delivering a monolithic application to you that you're going to put on your Windows system, I'm going to deliver a business need through a variety of parts. And so we look at the job that needs to get done, we break that into submodules, and then after we break that into parts, we deploy a component of each. So for example, in a broadcast facility, we need IQS. We need a console, right, as a mix interface. I need my phone lines, VXs. We didn't put the phone lines inside of the console to deliver you a converged solution. What we did was we gave you one container you can purchase, that's your phones in VXS, and another container you can purchase, that's your audio console. Now, using the beauty of Livewire and AES67 right on the same server, it's just like working with the hardware product. You're going to put in your channel numbers and say channel 1, 2, 3, 4 is hybrid 1 on your console, and your console is subscribed to your VXS. So it's breaking these things down to the right module size so that it's a big enough block that I know what it is, but it's a small enough piece that it can be moved around and slotted in and out and scale up and down in size to fit my organizational need.
So I'm guessing that as a software container, again, this is different than a virtual machine. A virtual machine is the operating system and everything sitting on top of a hypervisor, whereas a software container runs in a software container engine. Typically, we call this a Docker engine because that's the organization that is most prominent here, right?
Correct.
And yeah.
So the container, the container itself is just the software that's delivered, and there's a whole stack of software that enables running it. And so that stack, the main component is we have our container image, and that's just, think about that just like you think about an application image, right? It has to be compliant with the operating system you want to deploy it on. And so we take our container image that's compatible with our container runtime, which is a subcomponent of your container, of either your container engine or something you run independently. We recommend using Docker Engine. It's a well-established tool. So you've got your container, you've got Docker Engine, and we connect our container to Docker Engine. And then Docker Engine actually connects, and it's a Linux-based OS. We recommend Ubuntu, but you connect to the host OS, and then it does the virtualization at that level. So it does create this isolated ball in deployment that is just our container as a little module we're going to give you. And inside of the Linux host, it's completely protected from everything running adjacent to it. So when you run an IQS next to a VXS, those two pieces are completely isolated from one another, besides those Livewire channels you point at each other. And that's what allows it to fail gracefully, transparently, and independently, which I think all of us who have sat there and designed an air chain, those are three words we like, right? I know it broke, and it failed without breaking anything else up or downstream of it. And it told me it broke, right? Those are the three things that let us know how to do our jobs as broadcasters.
Jake, you said something a few minutes ago, and that is that we're already using software containers and we don't even realize it. And you mentioned PayPal, right? So I just brought up my PayPal app on my phone here, okay? And I'm going to send you $1. Okay, and I'm curious to see how. Yeah, get your phone, and this is all happening via containers and the internet and some big. I'm not sure what I'm trying to prove here, but I think it's kind of cool because I didn't know about containers until not too long ago, and I just sent $1 to Jacob Alderman, and let me know. I haven't gotten the confirmation just yet. I told it to send.
And I just got it, and I'll try and find a way to show this without showing too much of your information. But for our viewers at home, there's TWiRT with $1 next to it.
How about that?
So I mean, these are well-founded technologies, though. At this point, Docker started to really get some traction as a company in about 2013. They've done a number of open source initiatives to get broader adoption by the Googles, the Red Hats, the Amazons of the world to start adopting this workflow, who are now also big backing companies. So while it's newer than hypervising, this technology is here to stay, and it will scale, and it does work in deployment.
Gotcha.
It is cutting edge, and that's where we like to be as an organization, is looking at how do we deploy these solutions. And I know I'm sitting here and I ask the question myself. I'm a guy who I learned about virtualization on hypervisors. When I was first putting my toe in the water, it was all, you got to learn VMware, you got to learn Hyper-V. And some companies have made, and organizations have made a large investment in those platforms. The beautiful thing about a container is you can deploy it inside of a VM. So if you've already got one of those vendors in your facility, it's just a matter of spinning up a virtual machine, putting Linux on it, then putting Docker Engine on, then loading whatever one of our products you want to load on top, or any other container-based solution. One of the cool things about containers is there's a lot of things we need in our broadcast facilities, right? And there's a number of good open source projects out there for tools. How many guys run those, guys and gals at home run the Ubiquity access points, right?
Right.
The Ubiquity access points, I find the control software to be kind of a nightmare to keep running on a Windows machine. I don't like to have it on my laptop. It's a little bit hinky to work with. So eventually I put it in a VM, and then it was running there. And then I was poking around online, and I'll send you the link after the show for the show notes, linuxserver.io. And there's an open source community that took that application and put it in a container, and it's perfectly suited for that. You just need to, do a couple things as you configure it. Read the documentation, which is well written by the community. And Bob's your uncle, you've got a running instance of Ubiquiti's Unified controller in a container. So it's not just the audio tools, but some of our IT management tools also can go in there. Your network monitor is perfect to throw into a container. All of those pieces, parts. So you really can get a lot of mileage out of a single piece of metal by subdividing it. And that's it's a similar discussion that we've been having about hypervisors for the last 3 or 4 years is, hey, can I put all my automation PCs in a VM, right? I think one of your stations is doing that already, Kirk.
We've done that. Yeah. Yeah. And so are you saying that well, if you could, well, we're going to need to break in a minute, but kind of give me why would I want to do a software container instead of a VM? And I got a feeling it's because if I do a virtual machine, I've got a whole operating system running there. 95% of it, of a standard installation goes unused by the one app, the one thing that I really want to do. Whereas with a containerized software, I can run a whole bunch of those with a Docker engine, a runtime engine, and that's going to end up being able to more efficiently use the underlying operating system. In this case, we recommend Ubuntu for the stuff that we're doing, right?
Right. Yeah. There's a certain amount of you're doing double abstraction when you run containers in a VM, and even when you run a VM, it's less efficient than running a container because a container is intended to have a smaller footprint and require less hardware resources. There's a certain amount of you take your large 32 core 128 gig server, right, and put your hypervisor on it. That hypervisor software is going to occupy a larger base footprint than your Ubuntu OS is going to occupy. And that means you leave yourself more mileage on that piece of metal with containers. But it's all about what fits your facility and your needs. It's why we're here to help you with all of those, that whole gamut of, hey, I've already got a VMware instance. Can I put this on there? Yeah, we'll help you figure that out. It might be some solutions time with us to do that project with you. But it can be done that way. Or, if you're brand new to this and you've got no investment, we'd recommend going this direction just because you're going to have all of these benefits that come with it.
So, wow, this is really a whole new world. But, we've learned new things before, right? I remember when we went from tube FM transmitters to solid state FM transmitters. There were things to learn about the ventilation requirements, things to learn about, keeping water. Maybe it's more important to keep water or rain or drips out of a solid state transmitter than a tube transmitter. So there's all kinds of things to learn as technology moves forward. And this, I think, is a real turning point for a lot of broadcasters. Whether you instantiate your broadcast infrastructure offsite in a data center or public cloud like AWS, or whether you just do it on-site in your own hardware, and that's where I think a lot of people will start. That's where I've not only been starting myself. That's where we're continuing to go for our rather smaller operations. And the thing about you mentioned about what do people know about Docker or virtual machines, and of course, broadcasters cover everything from a mom and pop operation that have an occasional contract engineer when they can find that person to organizations that have large IT staff with the latest technology and training, and they know exactly what's going on. And you and me both deal with people everywhere in between. And the typically the larger organizations are like, this is a Docker, no problem. We know exactly how to do that. And of course, mom and pop operations may not have any idea. And that's why, hardware appliances are still available and more educational resources are becoming available to help people out like that, to see, hey, how small can we be for this still to make sense to virtualize some stuff? I kind of see, if you're a contract engineer, I kind of see an industry or a service for you. You get up to speed on virtual machines, hypervisors, and Docker and software containerizations. You get up to speed on that, and you're going to be able to help out radio stations a lot that you take care of. You're going to be able to, well, right now you already can, virtualize audio processing, automation systems, now mixing, now phone systems. I think in the near future, you'll be able to containerize or virtualize audio codecs. So there's a lot of things that you can do. We haven't figured out how to virtualize the transmitter yet. Oh, and by the way, Jake, since we announced, the folks at Telos announced the VXs, the software version of the VX, one person asked about that and wanted to confirm that this was true. And I said, yeah, the next thing we're working on, we're virtualizing your callers, and that way you can configure how you want them to behave. Wouldn't that be?
Yeah,
yes, I need a friendly caller right now. Friendly caller.
It would obsolete some features of the system. Let's put it that way.
Call screening. Who needs call screening? We make the callers ourselves.
I mean, it's
with AI, you're going to be able to do that someday. Hi, Jake. I listen to your show every day, and why, you're so handsome and smart, and I just love your show. You can AI your callers. Oh gosh,
it's going to be everyone's greatest hits every episode, and that's. But you hit on a lot there, Kirk, and it's all about what's right for you today, and also as we plan that next gen facility or that slow shift. I think one of the things we've seen a lot of in the industry was it was a big load to get from the last gen of consoles into the audio over IP consoles. And part of the beauty of adding containers into an existing AOIP install is it's just one more server, which you already have a fair number of those in the shop, and one more network connection. So that infrastructure piece that you've made an investment in is just another iterative investment into that. And it is a skills and a time to learn these tools. We've got some pretty good documentation. There's a demo for IQS that's available. You can register and try that at home. But that it's sort of is we just have to keep taking these little bites, but it really just builds on what you've already got started and going with. I already put together my Axia network, and it's got all these bits and bobs at the edges of it. Well, we're just going to say, that box over there that you just have the live wire port connected to, how about we pull that into a general server, right? Because that one you don't really need as a hardware box anymore. And that's sort of the opportunity as you start looking at how we do a job and what it does to pull the parts together.
We are talking to Jake Alderman. He is the program director for virtual initiatives at Telos Alliance. I'm sure I got the title wrong, but it's you're a director of virtual stuff. On This Week in Radio Tech, I'm Kirk Harnack, and we want to tell you about a couple of our sponsors that help make the show possible. This is not virtualized. This is an actual appliance. You plug it in, and as Jake was saying, hey, there's not, virtual stuff isn't for everywhere, every opportunity, or every situation. You got a small studio at home. You do podcasting from there, or maybe you do voice tracking from there. You do a radio show from there, and you want to put a caller on your podcast, on your show, and you don't have a POTS line at your home anymore, right? Well, use this. This is the Bluetooth audio gadget from angryaudio.com. The Bluetooth audio gadget, it connects right up to your cell phone with Bluetooth. So you even got a little spring-loaded pairing switch right there. And the Bluetooth audio gadget will let you have a phone conversation on your cell phone with your guest, with your callers, with your VIP, expert guest, and put that audio right through your audio console on the air. On the back of this thing are your XLR connectors to connect professionally to your audio console. There's a send jack there, so you can take your mix minus feed or your aux send from your small audio console and send that to the Bluetooth audio gadget. And then there's also outputs. There's a mono output, there's an AES digital output, and there's also stereo left and right outputs. Now, why would you have stereo if you're going to put callers on the air? Well, because the Bluetooth audio gadget is good for something else as well. If you have some songs on your phone, on your smartphone, if you have, for example, an interview that you've already done on your smartphone and you want to play that back in real time, you don't have to try to find the right connectors. And you've got a iPhone, so there really aren't the right connectors. You don't have an headphone jack anymore. You can play that back through Bluetooth and get high quality in the one-way mode from the phone to the Bluetooth audio gadget and to your audio console. In the two-way mode, it's phone quality. It's the lower quality that Bluetooth does, but it still sounds better than a typical phone line. So check this thing out. It's the Bluetooth audio gadget. Put your smartphone on the air, on your podcast, and do it in the confines of your small studio, your home. By the way, check the price on this thing. You're going to be surprised. It costs a lot less than I thought it did. Check it out from your favorite dealer, whoever that may be, as long as they sell products from Angry Audio. You can go to the website, angryaudio.com, and check that out. Hey, our show is also brought to you in part by these folks, Max Connect Wireless. We're going to hear from John Takak, and we'll be right back.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It has also given us the ability to expand as needed in a secure fashion.
You know, engineers across the country are loving this service, Max Connect Wireless. It makes hard to get to places accessible with IP data with a fixed IP address, as John Takak was just talking about. You can get all kinds of different 4G LTE modems from Max Connect Wireless. Talk to them, tell them what your situation is. If you need external antennas or the paddle antennas that come with them, whatever's going to work for you. And also if you want a dual carrier Max Connect Wireless modem, they have those as well. It's not the modem that makes the difference, though. It's the Max Connect Wireless SIM card inside that makes all the difference. You get prioritized data and a fixed IP address so you can access your transmitter site, but you can also go out and do live remote broadcasts, even from places where it's really crowded and all kinds of crazy people are on their cell phones. You get prioritized data from Max Connect Wireless. Check them out. Hey, it's Kirk Harnack and Jake Alderman, and Jake is here to he's the program manager of virtual solutions. There we go, at Telos Alliance. Jake, I'm not sure where we want to go next. You've kind of described, apps when they're appropriate, services and containers and virtual machines. Where do you want to go next with the conversation? What's important to you to get across?
I think one of the things, Kirk, and we talked about it a little bit earlier today, is how does cloud fit into this picture, right? How do I make that decision between what goes on-prem and what goes off-prem? Because one of the things, and I think it's when we all are starting to learn terms. To go back to the comment about learning, right? You don't do learning in a vacuum, and you sort of hear these buzzwords: containers, VMs, cloud. There's some big scariness about cloud is often what I find. It's going to the cloud, man. It's going to be hard. Or you have the Dilbert comics, which the manager walks through and says, just put it in a container. Why? We're going to deploy it on the cloud. And there's sort of those kidding jokes put aside, right? Like it's just as easy to make these changes. And as the implementation specialists in this world, we all know that changing any piece of gear has wide-ranging ripple. So if we start talking about moving out of the facility, again, it goes back to what that job is that we're trying to take beyond the four walls of our shop. For a disaster recovery tool, right? If you're going to have a whole virtual studio in the cloud, there's ways to start thinking about and planning for that situation. But the majority of the conversation right now for the products that are in the marketplace, whether they're ours or others, are focused in that on-premise piece. And I think it's really important to, when we start exploring and trying to learn and figure out how do I start to put this into my place, that key nugget of knowledge starts to simplify the discussion of, I want that IQS to be hooked up to my Fusion studio down the hallway. Well, we definitely want to be looking at putting that in the facility today, because that's where the technology's at, is bandwidth and codecs and other parts become available in this infrastructure. That conversation will change over time, but the immediate things that our products are capable of doing today is they're still designed to be in the facility. So some people see container and they go, oh, well, they're trying to ship my radio station off beyond my four walls, and I'm going to lose my control as the local guy. That's not necessarily the whole story here. is not that these virtual or containerized products are meant to ship everything out of your building completely. I've been the guy who's lost all my IP codecs going to my STL, and I've had to run and grab the patch cables and slam them into the patch bay that I cursed my boss for making me put in, to change an audio route because we had issues downstream or upstream, right? Or you're grabbing the XLR cable and you're going physically out of the back of the playout machine, which still had a sound card in it, and you're plugging it right into your codec, right? We know those things are still there. So, and going to the cloud just adds another layer of that complexity. So if it's going to be self-contained, it's something maybe to start thinking about. But if it's going to be interconnected, that brings a whole nother layer of complexity. And that transitions sort of the next thing I'd like to talk about, which is how do I actually start to put these things into practice, right? We've talked for half the show about what they are.
Yeah.
How do I start to do this?
Okay. Yeah.
And I think for all of us, at least there's two ways you can do it, right? You pick a platform. So you can say, I'm going to go with containers and I'm going to start building my expertise there. Or I'm going to go with VMware and I'm going to build my expertise there and then look for projects to put into those platforms. Or the other way is to pick a project. And I personally find the pick a project to put into virtualization an easier sell than picking a platform and trying to shoehorn what I'm doing into it necessarily.
Pick a project. Okay. And also you may not have choice of the platform. Like if I said, well, I want IQS, I want a virtual audio console and I want to do it in a virtual machine. Well, you kind of are, but it's going to be a containerized software on top of that. So you've got to look at what you want to do and think about it as a project, and then get with your vendors and see, okay, how are you going to help me how are you going to help me do this?
Right, exactly. So it's sort of, and that's why picking the project as a starting point is sometimes there's some negotiating room. Like you can do IQS, but you're still deploying the container into a hypervisor. So you're going to do both then in that case, if you want to go that route of building a system you've already got VMware and you just want to put IQS onto it. That's both of those technologies now, right? Whereas if our Pathfinder Core Pro product has been available for a few years now, as a virtual machine. And so if you're looking at upgrading your Pathfinder server and you want to get out of the reliability that Windows servers can sometimes have and move over to something that has more of an appliance feel to it, our VM ISO is a great solution to that. And you're upgrading into a whole new feature set of Pathfinder. But that also currently is not available as a container-based solution, right? So now you're going to have a hypervisor in your facility to run that application. So it's pick your project and then start to figure out what it's going to be and whether that's a production room or I think, we're still a year ago, we were all trying to get out of the facility as fast as we could, right? Or find ways to break our teams up. Maybe you figured out that, hey, throwing that Mackie in the conference room was a really great idea, but I wish it was on the network. I wish it was a little bit more tightly integrated with my AOIP shop. Maybe you're going to be looking at IQS to fill that need. So the project is sometimes going to govern the technology we're going to learn. And we can't force it the other way around 100% of the time.
You mentioned something about things being on the network, and the basis for all of this stuff going forward is that everything is networked. Of course, we recommend Livewire, AES67. There are other networking topology protocols out there. Most of them also have AES67 as an available protocol, since that's such an industry standard. But if you've got some analog gear laying around here or there and you can't really access it remotely, then you're not really pushing yourself forward. That's why everything is Steve Church years ago said, I believe that eventually everything is going to be networked. Satellite receivers are going to have an AOIP jack on the back. And sure enough, they do. Transmitters, FM transmitters, maybe AM transmitters, but FM transmitters are going to have a live wire jack on the back. And sure enough, some of them do. There's even a microphone from Neumann that has an AES67 jack on it. So you can, go directly without going through, somebody else's node or blade or something like that to convert it over to AOIP. It does it internally. But that's got to happen. And luckily, very fortunately, at my own radio stations, just about everything is. Except for the microphones and the headphones. And I guess we have some analog satellite receivers that spit out analog, but they go straight into nodes. So now all that is on the network. And Jake, the serendipitous thing for me is I do so much engineering for my own radio stations remotely. I'm a 6.5, 7 hour drive away from them. And yet I can control and adjust and even fix most of the things that I need to do. We switched over to new automation systems at my stations. And I was only there for a short time to physically load them in the rack and initially get them configured with remote access software on them. Everything else I've done totally remotely. And so has we even got the automation vendor to put the automation systems on. They did it totally remotely. As long as you know you've got access to the thing, you can do almost anything. I'm talking too much. Go ahead, Jake.
You're talking just the right amount, Kirk. And that's one of the big leveraging points, right? Is that I think we've gotten used to a world over the last year, and one of where things besides our work matter a little bit differently than they used to. And I know this isn't necessarily completely broadcast focused, but being at the kids' soccer game matters. Being home for dinner matters. And that means that, I live in a major market. It's a pain in the butt with traffic to get to where a lot of the stations are located downtown. And the transmitter sites were built in what were cornfields at the time that now are suburbs. And I remember when I would work, I lived downtown at one point, and I remember making that reverse commute. You're driving out to the transmitter in the morning, and it's 6, 7 in the morning, and you're sitting in traffic for an hour, and you're turning around, and now you're driving the reverse, and that's another hour and a half, 2 hours in traffic to get back to the studios, and then you're doing stuff at the studios for 3-4 hours. We're never going to be able to solder and go put a DB25 in the back of a GPIO port. Or a DB15 in the back of a GPIO port remotely. But right. I'm going to do some Linux updates. I'm going to work on software updates or system stuff. Yeah, there's a certain comfort factor to being in the facility, but you can prep your facility to roll all those bank updates while you're sitting at home in the afternoon, cleaning your email, doing some other stuff. And I think that remote management of a facility is really critical to this. And it goes to those 3 points I mentioned earlier. We design software-based solutions to fail transparently, independently, and gracefully. And if you don't embrace we need to know when we're going to have not when it's going to break, but when it does break, where the breakage is in the system. That only that component fails. So even if I'm running 6 IQSs all on one machine, right? If one goes down, the other 5 are unimpacted.
Yeah. Okay.
And there's the transparent and the graceful factor. So transparent means I know about it, and the graceful factor is it fails in a way that it doesn't hopefully just break everything. Now with audio, that's really hard to deliver, that graceful failure. So what graceful failure might mean in your facility is you invest the time to set up automated scripting. And so that automation knows, an orchestration behind the scenes can spot the failure, see the failure, know what a human would do. When you joke about AI, right? Software running software at this point, know what we would want it to do and try and fix the problem on its own. Not that you're being made irrelevant in that chain, but it's a heck of a lot nicer when you get the email and products like our Pathfinder system or other control systems from other vendors do this already for our hardware products, right? My node, my blade, my whichever audio interface I have running on my network fails, and I'm aware of it because my monitoring system, the monitoring component of an automation system knows, and it orchestrates a change to move my air chains from A to B node, and then it knows that B node is also connected to all of these other resources. You can do all of that redundancy design into your system. And so that's where I think there's a big leveraging point as we start to make these moves.
Hey, we need to cover one more topic really quickly before we take our last break, and then we'll have our tip of the week right after that. But if people want to get started at home playing with this, I got to know something about routers because I went through a lot of routers over the last 20 years, mostly because they would just break and I'd have to buy a new one. But I got to learn, a lot about port forwarding, and there's more sophisticated things I don't know. I still have to look up, but there's a lot that I've learned just by doing. And the same thing with playing with Linux distributions, for example, and playing with server hardware. What could an engineer do at home to teach himself about containerized software? What do I need to get started? Can I start with just some cast off PC and put Linux on it?
So if you're just going to run some stuff at home in the lab, a cast off PC is great. Now there's a difference here between what I call production grade and lab grade gear, right? I've got a room here in the basement at the house that I've got, a couple machines running in that I do various testing on. None of those machines are machines I'd put into a production environment today, right? So if you're just trying to make the jump in, there's a lot of hardware that's acceptable. Load Ubuntu onto it, use our tools and load our IQS product if you want to demo it. Or if you're just looking to try that Ubiquity, their system management tool, follow, and I'll again give Kirk the stuff to put it in the show notes. Follow their Linux server IO directions to install that product. There certainly are ways to do it. The legacy automation server is great for that. That shift to production, though, we got to make it clear when we're talking with station management and they go, this is really cool, we want it in the Air Studio tomorrow. Okay, there's this other layer of investment we need to make so this is broadcast reliable, right? And that's the careful stepping stone out of the lab and into production. But for generally testing, if you've got, I know a lot of us have got retired Dell servers from various builds or retired automation PCs that are in the back room. I wouldn't recommend the sales guy's computer, right? Something that's of a workstation or server grade hardware is really what we're looking for when you start getting into deploying either a hypervisor or a container host to do it at scale, and is going to give you some of those feature sets. The desktop grade stuff, you can run into some weird hinky issues that are kind of untroubleshootable because it ends up being a hardware dependency, not a software level.
Now, if people want to play with containers, of course, you mentioned that IQS, the virtual audio console from Axia, that is available on a demo basis. You fill out a form and yet you need an account with Quay.io, which is our repository for software containers. Anyway, you can end up getting it at no charge. It's 4 faders, and it does put some tones and stuff in the audio to keep you from using it on the air without paying for a license. Also, I would point out that it's really not going to do much unless you have some other sources of LiveWire or AES67 audio and some clocking on your network. So you can build it, but you won't have any audio unless you actually have some sources that are on the network. Jay, can you think of another example or two of there's some open source softwares you can get as a Docker container that does something interesting, so you can just kind of test your skill and work through the process of installing these?
Yeah, Plex Media Server is the one that I recommend to a lot of people.
Oh, okay.
We all love, most of us who work in radio love music. Some of us also love movies or television shows, and so you can get a Plex Media Server instance running. You can start loading it up with all your favorite media, just like you can, run that as they've got versions, you can really try it, hardware, VM, and container. There's versions for all three out there. There are people who build ISO images that you can install Plex right on a piece of hardware. You can see what it looks like on hardware. You could try it as a VM, and then you could graduate up to the container, and you could see what it's like to deploy it in all three of those cases. That's one that I personally use on a regular. That's how I run my media server. And then there's another container, if you're going to get into this, called Portainer. Portainer. And Portainer is a container for running containers. And I know that it's again the joke. Software is going to run software one day.
Yeah.
And so that's a really great tool if you're just getting into this. You install it. It opens as a web browser. It opens in a web browser, and you can start and stop your containers, add new containers to the system. It adds a graphical layer and avoids the CLI, which can be challenging if you're just getting into this. And just to be completely transparent, this is only a journey a lot of us have started a few years ago. I personally was doing a lot of the research and picking these parts up. over time, and that, it's not that you wake up one day and it's all in your head and this is easy. It's you got to try it. And so, diving into try Plex, or setting up a Linux instance, putting Portainer on it, and just getting in there. A lot of us in my travels and meeting industry peers, getting our sleeves rolled up is the best way we seem to start picking up new technology.
We spoke very briefly at the beginning of the show about a real-time operating system. I want to point out that if you've been accustomed to using something like an Axia audio console with a mixing engine, or a Core 16, Core 32, or a Power Station, those have a Linux built-in that is a real-time operating system. We don't have time to go into all that, but I want to point out that a containerized software like Docker running on Ubuntu, that's not a real-time operating system. And so the one thing at the moment that you don't get is this mixing engine cannot generate a live wire live stream. That's a very low latency stream. It's also 4,000 packets per second. It can ingest those, it can receive those, and it can also receive and generate the AES67 1 millisecond packet. And so that is a pretty low latency packet right there. But I want to point out that limitation. The other slight limitation we want to caution people against: don't try to do something like IQS or VXs. These near real time that have live audio going on. Don't start with Windows and then put Docker desktop on top of Windows and then put the container on top of that. That's not a good not a good idea, right, Jake?
Yeah. So real-time audio has a performance constraint to it, and that's why on hardware products we used real-time OS, and some things like super low latency packets aren't available today in our products. The Docker desktop is slightly different in the way it's constrained, which is that the way that product works is it installs, and both Mac and Windows have virtualization built into them. So Windows, it's called Hyper-V. Mac, I don't have the name off the back of my hand, but it has an integrated hypervising tool in it that allows products like Parallels, which many Mac users use to get Windows on their desktop available.
Sure.
And so Docker Desktop bolts in and utilizes those built-in technologies to build a VM that installs Linux, that installs Docker Engine, and a limited tool set. So you've got hardware, your operating system, like Mac or Windows, which is an optimized, a virtual machine, Linux, Docker Engine installed, your container. So you've got 6 or 7 layers there.
Layers, okay, yeah.
Between you and hardware.
Much, yeah. If you're doing something simple, if you got a Docker for word processing, okay, maybe that's all right. But if you're trying to handle some live audio, it's not. Jake, we've got to take a quick break. We'll be back with your tip of the week in just a minute. Our show is brought to you in part by our friends at Voxpro. Be right back.
Hey, what's happening? St. John here, coming to you from Command Central, and wanted to tell you about the absolute best partner you can have in radio. I'm talking about, boom, Wheatstone's Voxpro. Now, a lot of folks have used previous versions of Voxpro, all awesome, but I want to tell you about some of my favorite new features in 7. And for folks who've never used Voxpro before, I'm about to tell you why it's an absolute game changer and essential for really fast-paced multi-element radio. Lots of different audio software out there. Why Voxpro? Because it was designed for radio. It's the only software designed to do what we needed to do, which is record, edit, playback in real time. When I say lightning fast, I'm going to show you how fast you can edit stuff up in Voxpro right now. Literally 3 clicks on the controller, mark left, mark right, everything that gets marked, you hit delete, it goes away. It's literally that fast. So we're going to take this part right here. Boom, from caller 9 to him saying, I'm ready.
5, ready for that secret sound.
Boom, all of that stuff, hit delete, it goes away. Here's your edit.
You are tackling secret sound, caller 9.
I'm ready, St. John.
One of the best features of version 7, this is awesome. It's effects macros, and you can literally put a chain of effects together so that instead of having to normalize a phone bit and then use noise reduction on it and EQ it and all that, you can literally build a chain. One button, this one's called call right here. I just click that. All of those processes happen instantaneously. Literally saves 80% of your editing and cleanup time. Final thing that I love about Voxpro, and there's so much more to get into, but one of my favorite things, you can load it on a laptop. I've literally done my show from a hotel room in Armenia to the conference room at, this was fun, jury duty. Great thing, no one could tell the difference. Voxpro makes it totally easy. Telling you, if you're looking for the best on-air partner, call my friends at Wheatstone, ask them about Voxpro, and you will be glad you did.
And you can get Voxpro from Broadcaster's General Store. Go to the website bgs.cc, bgs.cc, or call them. You know, they're set up for phone calls. They're really lovely on the phone at 352-622-7700, 352-622-7700. We're almost out of time. Jake, you got a tip of the week for us, please.
Call your friends. And
phone a friend.
Phone a friend. We're all going to be going through this journey of moving out of our metal or vendor-based metal, right? Whether that's Telos or other, into high-density solutions and virtualizing products, whether it's in a VM, in a hypervisor. But we're all sort of coming down this train in a lot of facilities. And again, there's always a place for analog. But if you're already in an AOIP network, starting to leverage virtualization makes a lot of sense. But this isn't a trivial jump. And yes, there are certain things we all keep as our secret sauce, right? You lock that Omnia 11 because you worked really hard to make that preset so the station's the loudest, cleanest thing in the market. And you don't want the guy down the street who's got the other rocker to know what you're doing, right?
Right.
This isn't the case with this stuff. This is your infrastructure. Everybody's going to have some of the same challenges. Call your friends as you're going through it. Bounce the ideas around. People will bring different perspective to the table. And you learn so much more working as a team than you do working alone. And to be honest, a lot of the information relayed here today is because I have one of the best teams I get to work with. It would take me too long to give them all an individual shout out. We just have an hour of TWiRT of me giving shout outs. But I'm fortunate to work at Telos Alliance with some really fantastic people.
There's plenty of Docker and containerized software education available online on YouTube. There's courses available. I got a feeling that I'm in SBE, so I got a feeling that we're going to start doing some webinars at SBE eventually to get Docker. Whatever's out there technologically that radio and broadcast engineers need to know about. You're going to find it out there from SBE, from SMPTE, from IEEE, on YouTube. There's all kinds of organizations there. So, and your vendor should be able to help you out. If they can't, give you a complete education in this, they can at least point you in the right direction for what you need to know. Jake, we got to go. Thank you for being with us. Jake Alderman, the program director of Virtual Solutions here at the Telos Alliance. Virtual Solutions. I don't know why I can't think of the word solutions. I'm just going to keep calling you Jake if you don't mind.
It's just fine. So okay. Thank you for having me this week, Kirk. It's been a real pleasure to be back on the show.
So, thank you. Sounds like we could easily spend 2 hours here talking about this, and I'm sure we'll hear more as either more products become available, more techniques, and more learning becomes available. Hey, we got to go. A big thanks to Suncast for handling the quick conversation and doing all the video switching. Suncast, thank you very much. Also, thanks to Andrew Zarian, the founder of the GFQ Network, home of other fine podcasts, including things like What the Tech. We got to go. We'll see you next week on This Week in Radio Tech. Bye-bye.